Hi friends, in this particular video I am giving you brief idea about the block diagram as well as pin diagram of 8255 IC. Okay, so in the previous video I already explained the introduction part of 8255. Let us see here what is the block diagram of 8255 and what are the various blocks present, and similarly the pin diagram of 8255, and let us see functioning of each pin. Okay, detailedly here. See here. So now this is your 8255. Okay, also call it as a PPI. PPI means it's a programmable peripheral interface. Okay, programmable peripheral interface. So in order to interface your 8086 with other peripheral devices, generally 8255 is used. That's why name comes like a programmable peripheral interface. Now let us see straight away block diagram of 8255 as well as pin diagram. Let us see here once. Now see here, 8255 requires 5 volts power supply. Okay, and grounding is also essential. And let us see block diagram. This is block diagram, and this side we observe pin diagram. Total of 40 pins are present. Okay. Now let us see main blocks. So see here, there is a group A. In that group A, there is a port A. Port A having how many pins? 8. PA0 to PA7. And all ports are ready to perform IO operation. Nothing but input or output. If it is input like this, if it is output, this is the arrow for output, this is the arrow for input. If processor is this side. Okay, then similarly, this is a group A, 2 parts, port A 8 and port C upper. Port C upper means 4. PC4 to PC7 also comes under group A. Now then these two comes under group B. Group B, in that port C lower 4 bits, name it as PC0 to PC3, and port B 8 pins. Port B 8 and port C lower. These two comes under group B. These two comes under group A. Then there is a control block. This block controls group A. That's why name comes like a group A control. And this group A controls here. Group A control will control group A signal. See this one as well as this one. Both are controlled. Similarly, let us say group B control. Group B control also controls port C lower as well as port B. Okay. Now these two will further. These two are controlled by read-write control logic. This is the control logic. Okay, according to this control logic, group A and group B controls are operating. According to these two control blocks, ports are operating. Okay, and read-write control logic is controlled by processor based on the command coming from the processor. Now this 8255 performs either read operation or write operation like that. Then here there is a 8 data lines are available, and there is a data bus buffer. And the role of this data bus buffer is simply transmitting data between 8255 and lower byte of processor. Okay, lower data byte of processor or lower data bus of the processor. Okay, so like that we have connections of 8255. So in order to operate this 8255, we should activate this signal, CS bar signal. Let us see how many pins are present. Port A having 8, they are bidirectional. Port C upper also 4, port C lower also 4, and port B 8. Total 3 ports, nothing but 24 here. 24 here, 8 data lines. 24 plus 8, 32, 33, 34, 35, 36, 37, 38, and ground and power supply. Total 40 pins are there. If you see same way here also 40 pins, 1 to 40, same are distributing here. Right. So coming to group A port A. So group A port A is having 8 IO lines, and they are ready to perform either input operation or output. Similarly, port C lower as well as port C upper and port C lower, they are also ready for performing IO operation. So all ports are ready to perform IO operation, and all these ports are controlled by read-write control logic. So see here, all these blocks are controlled by read-write control logic. See here, there is a connection. So every ports is controlled by read-write control logic, and read-write control logic also controls group B control as well as group A control. And group A control further controls group A related ports, and group B control further controls group B related ports. But overall, all these blocks are controlled by read-write control logic. Now let us say functioning of each data bus buffer is a one block, and with this data bus buffer contains 8 data lines D0 to D7, and these data lines are connected to processor data bus. Okay, and it's a bidirectional. So for example, processor wants to send data from processor want to send data to external device, for example 8257 or any IO device, then what happens? In that case, data bus buffer receiving the data from the processor and transmitting same data to any of the port. With the help of port, it will transmit data to external device. Here all these ports are connected to external devices. Okay, so for example, external device size is 8-bit, then one port is enough. Like that, we can analyze block diagram. Let us see pin diagram easily. And here read-write control logic is also very important, remember. So as per the command from the processor, this block will control the ports. Okay, accordingly ports will receive the data or transmitting the data. Okay, and here also it requires 5 volts power supply and one ground is essential. Now let us see here. Now as per manufacturer sequence, we follow same order. So if we consider 8255, in that 1 to 20 in one side, similarly 21 to 40 other side. So in that pin number 1 is PA3, then PA2, PA1, PA0. Means port A 4 pins comes in the left side, whereas port A remaining 4 pins comes on the right side with the top positions. Okay, you remember A0 to A3 here increasing order, or it starts from 1, now 3 to 1 0 decreasing order. See, whereas 37, 38, no, order should be like this. So 37, 38, 39, 40, if you observe, they are also decreasing order. Like that we can remember. So if you go path like this, 1 to 4 decreasing order and 37 to 40 also, PA7 to PA4 decreasing order. Like that we can remember. So similarly we have read bar, CS bar, ground, 2 address lines are present, A1 and A0. Here also A1 and A0, and ports total 8 pins, PC7 to PC7 to PC4 comes first, then PC0 to PC3. So here PC upper in decreasing order, PC lower in increasing order. Then PB0, PB1, PB2, and it will be continue like that. PB0 to PB7. Okay, same increasing order. Then VCC, then D7 to D0, 8 data lines, then reset. Whenever reset is occurred, let us see what happens. Right bar, PA7, PA6, PA5 and PA4, like that total 40 pins are present. Let us see functioning of each port. See here first port A. So port A is mainly used for only 8-bit input or output operation. If it is input, it's act like a buffer, and if it is output, it's act like a latch. But this port A is ready to perform either input or output operation. Okay, so this is only the operation for port A. Next, coming to read bar. Whenever read bar is activating, then what happens? If read bar is activating, then the 8255 is ready to receiving the data. Whenever read bar is activating, then 8255 is ready to receiving the data. Okay, now CS bar. Whenever CS bar is activating, then only this 8255 is ready to perform either input operation or output operation. So CS bar is chip selecting signal. Whenever the signal is inactive, assume, then 8255 is not ready to perform either input or output. So chip selecting signal must be activating for performing any IO operation. Okay, this is very essential. And the signal is activated with the help of external decoder. So decoder will provide address for this 8255, and this decoder also activating CS bar signal. Okay, right. Coming to ground. So ground pin is essential, and this pin 7 is ground, and this is connected to external ground. So and this pin provides the protection against the overcurrents. And here 2 address lines are there, A0 and A1. These 2 address lines are connected to processor address bus. Okay, and processor address bus may give you either 0 or 1. Accordingly, we have a different set of selections of ports. For example, A0 and A1 both are 0, 0. Then we get port A selection. If it is 0, 1, then port B selection. If it is 1, 0, port C selection. If it is 1, 1, then control word register. So based on A0 and A1, we can select ports or control word register. Because of 2 inputs, we have 4 combinations. So 3 ports, port A, port B, port C, and control word register. We can select easily based on these 2 A0 and A1. Now coming to PC0 to PC7 to PC4 and PC0 to PC3. So out of 3 ports, port C only can be divided into either port C upper or port C lower. That is one point. Port C can be divided into 2 parts, port C lower and port C upper, and each size is 4-bit. Second point is the ports mainly perform either input operation or output operation. And based on the selection of MSB bit of control word register, this port then 8255 operates in BSR mode, means bit set reset mode. So the bit set reset mode is applicable to port C. So port C having mainly 3 things. One is it is divided into 2 parts, port C upper and port C lower. Second, each size of port is 4-bit. Each size of port C upper and port C lower is 4-bit. And port C also ready to perform either input or output operation. And third, based on the selection of control word register, in that also MSB bit, if it is 0, then the 8255 operates in BSR mode, nothing but bit set reset mode for port C. So because of the BSR mode, we can set or reset the individual bits of port C. That is possible in BSR mode. Okay, that's another advantage of port C. Now similar to next one is PB0 to PB7. Port B, PB0 to PB7 pins are used like a port A. These 8 are used for either input or output operation only. And if it is input, we are calling as a buffer. If it is output, we are calling as a latch. Then this is, it's a power supply pin. Pin number 26 is a power supply pin, and this pin receives 5 volts power supply. Okay, then only 8255 is operating. Then D7 to D0. So 8255 also having 8 data lines, D7 to D0, and these 8 data lines are connected to processor data bus. So processor and these 8 data lines are bidirectional data lines, and processor can transmit, can access data with the help of these data lines only. Okay, and processor can access data, or processor can transmit data, or processor can receive data either from external device or sending data to external device through these 8 data lines. Now reset. Here also whenever reset is occurred, what happens? The control word register is cleared, all ports are cleared, like that. Reset is also present. If whenever reset is activating for at least 4 machine cycles, then automatically like a 8086 how reset is clearing the registers. Here also whenever reset is activating, ports and control word register are cleared. Then write bar. Whenever write bar is activating, what happens? 8255 writes data to external device. Okay, whenever write bar is activating, 8255 writes data to external device. Then port A pins. Already we discussed. Like that, we can analyze the block diagram as well as pin diagram of 8255. Simply, 8255 is act like a intermediate device between processor and external device. So, for example, processor wants to receive data from external device. Simply, processor activating the corresponding control signals. Accordingly, data will be transmitting from external device to 8255. Then from 8255 to processor. Let's suppose processor wants to write data to external device. Then simply processor transmitting data to 8255. Then 8255 transmitting its data to external device. Like that, it's act like a mediator for data accessing or data transmission between processor and external device. And here pins are ready to perform IO operation. And additionally, port C is ready to perform BSR mode is possible for port C. But for port, but all 3 ports are ready to perform IO. In addition to that IO operation, port C performing BSR mode of operation. And port C can be divided into 2 parts: port C lower and port C upper. Okay. And like that we have read bar, write bar, and this 8255 comes into operation only by activating CS bar signal. Okay, and the CS bar is activating with the help of external decoder, and that decoder is receiving address line from the processor. So indirectly, 8255 is controlled by processor only. And read write control logic and data bus buffer both are controlled by processor. Based on the command from the processor, read write control logic will control the ports as well as corresponding controls, group A, group B controls. Okay, accordingly, ports are performing either input or output operation. Okay, like that we can analyze the block diagram as well as the pin diagram of 8255. Okay, in the coming video, let us say detailedly what is control word register and how we can make IO mode of operation and how we can make BSR mode of operation with the help of programmings. Okay, we'll see detailedly. Okay, right. So okay, I think you understand block diagram as well as the pin diagram of 8255. Okay, now. Okay, thank you for watching my video. If you really like, please kindly share my video to your friends and subscribe my channel. Thank you.